Imagine spending nearly a decade building something the size of a grand piano, loading it onto a rocket, and firing it into the darkness at more than 36,000 miles per hour, aimed at a tiny, frozen world so far away that even light takes more than 4 hours to make the one-way trip. Imagine watching that spacecraft crawl across the solar system for 9.5 years, crossing 3 billion miles of absolute emptiness, while you waited and hoped and wondered what you would find when it finally arrived. And then imagine that when it got there, when humanity finally got its first real look at the distant, frozen dot that had been nothing more than a blur for 85 years, the world you found was nothing like the dead, simple frozen rock everyone expected. It was alive. It had mountains. It had glaciers. It had a layered sky glowing with hazes that defied the models. It had a beating heart. And beneath all that frozen silence, it may have been hiding a liquid ocean. This is the story of what NASA's New Horizons spacecraft discovered at Pluto, and why those discoveries didn't just change what we know about a single distant world, but forced scientists to rethink the entire outer solar system. Pluto was discovered by Clyde Tombaugh in 1930 and named by schoolgirl Venetia Burney for the Roman god of the underworld. For generations, it was known to the public and to schoolchildren as the ninth planet, the smallest, the most distant, the final frontier of our solar system's family. But even professional astronomers had to admit they knew almost nothing about it. Every image ever taken of Pluto before 2015 showed little more than a smudged, pixelated blob of light. Even the Hubble Space Telescope, orbiting high above Earth's blurring atmosphere, could only produce images showing vague patches of light and darken. Pluto's surface, tantalizing hints, but nothing more. Scientists could measure Pluto's mass, its approximate size, the rough composition of its surface ices, and the existence of its large moon Charon. Beyond that, Pluto was a mystery wrapped in darkness, wrapped in cold. Then the call went out for a mission to change that. Starting in the late 1980s, planetary scientist Alan Stern and other Pluto enthusiasts fought for the dwarf planet to receive the same treatment as all its kin. NASA spacecraft had visited all the other planets to study them up close. In 2001, Stern and his colleagues won a NASA competition to lead a Pluto mission. The spacecraft that resulted was called New Horizons, and it was a marvel of engineering economy. A compact, piano-sized probe carrying 7 scientific instruments, powered not by solar panels, useless at such distances from the sun, but by the heat of decaying plutonium. It launched in January 2006 on a solar escape trajectory at 58,500 kilometers per hour, the fastest Earth departure of any spacecraft, carrying 430 of those 700 human names on a CD, a Pluto not yet explored postage stamp, and 30 grams of Clyde Tombaugh's ashes. It would not reach its destination for nearly a decade. After a brief encounter with asteroid 132524 APL, New Horizons proceeded to Jupiter, making its closest approach on February 28, 2007, at a distance of 2.3 million kilometers. That flyby served a dual purpose. It gave the spacecraft a gravitational boost that dramatically increased its speed toward Pluto, and it gave the science team a chance to test all of New Horizons' instruments against a real planetary target before the main event. The Jupiter encounter worked beautifully. Then New Horizons kept going, deeper, darker, colder, spending most of the next 8 years in a state of electronic hibernation to preserve its systems, waking only occasionally to check in with the scientists on Earth and confirm it was still healthy and still flying true. By early 2015, as New Horizons began waking up in earnest and its cameras started turning toward Pluto, the scientific world held its collective breath. The images were still blurry at first, but as July 14th approached and the distance shrank from millions of kilometers to hundreds of thousands, something remarkable began to resolve out of the noise. A bright region, a strikingly white feature, a shape that looked unmistakably like a heart. On July 14, 2015, New Horizons became the first spacecraft to fly by Pluto, coming within 7,750 miles of its surface. It passed so quickly, its speed relative to Pluto was more than 14 kilometers per second, that the entire closest approach phase lasted only a matter of minutes. During those minutes, its cameras were snapping continuously, its spectrometers were sampling the atmosphere, its particle detectors were probing the interaction between Pluto's environment and the solar wind, and its radio science instruments were measuring the density and structure of the atmosphere by listening to how the spacecraft's radio signal was bent and attenuated as it passed behind Pluto's edge. Everything that New Horizons would ever know about Pluto up close was captured in that brief, furious window. It would then take 16 months to send all of that data back to Earth across billions of kilometers of space. But what emerged from that data, discovery by discovery, image by image, reshaped everything. The first thing that struck everyone, scientists and the public alike, was the heart. The spacecraft revealed what is now one of Pluto's most famous features, a heart-shaped region roughly 5,600 kilometers wide. Its western lobe, called Sputnik Planitia, is a nitrogen glacier atop an ancient impact basin. This enormous white plain sits near Pluto's equator, gleaming so brightly against the surrounding terrain that it dominates the view from any distance. But the heart is far more than a beautiful feature to photograph. It is, in a very real sense, the engine that drives much of what happens on Pluto. Sputnik Planitia is not a static sheet of frozen nitrogen. It is actively churning. Solid nitrogen is soft and malleable, allowing a planetary heating process that typically takes place underground to be on full display. The nitrogen ice at the bottom of the basin is very slightly warmed from below, most likely by the residual heat deep within Pluto's rocky core, and it rises to the surface in slow, enormous convection cells, each one hundreds of kilometers across. As each cell rises, spreads out, cools, and sinks again, the surface of Sputnik Planitia develops. A distinctive polygonal pattern, irregular shapes whose boundaries are constantly, slowly shifting. This is a glacier that moves in geological slow motion, reshaping itself over millions of years, covering and uncovering features on the basin floor in an endless cycle of frozen circulation. Mission co-investigator John Spencer of the Southwest Research Institute said of these flowing ices, "We've only seen surfaces like this on active worlds like Earth and Mars, and the heart influences far more than its own surface." Sputnik Planitia literally forced the dwarf planet to reorient itself so the basin now faces almost squarely opposite Pluto's moon, Charon. The mechanism behind this is a kind of gravitational inevitability. Sputnik Planitia is an enormous mass of dense nitrogen ice sitting in a deep basin. And over time, the gravitational interplay between Pluto and Charon caused the entire planet to slowly rotate, to tip and shift, until this heavy feature settled into the most gravitationally stable position, locked permanently facing away from Charon. An entire planet reoriented itself around the weight of its own glacier. The scale of that process is almost too strange to fully absorb. And the ice volcanoes. Reitmans and Picardmans are two enormous dome-like structures on Pluto's surface, each potentially hundreds of kilometers across and several kilometers tall. They are candidate cryovolcanoes, structures that may have erupted, not magma, but slushy mixtures of water, ammonia, and methane, oozing and flowing across the landscape in geological deep time. Evidence of ammonia-rich materials at sites on Pluto's surface has been found in the spectral data from New Horizons, and ammonia is a significant indicator of relatively recent cryovolcanic activity, because it would break down quickly under the bombardment of radiation unless it had been deposited in the geologically recent past. Whether these structures are truly active or merely ancient remnants of a more volcanically busy era is still debated, but the fact that the conversation exists at all speaks to how radically Pluto overturned scientific expectations. All of this was discovered from a single flyby, a spacecraft traveling at roughly 49,000 kilometers per hour, passing Pluto in the space of a few hours, its cameras and instruments capturing everything they could before the dwarf planet receded into the distance. The closest approach lasted only a brief window. Then, New Horizons was passed, looking back at a crescent Pluto backlit by a distant sun, the atmosphere glowing blue with layers of photochemical haze, a deep, rich blue above a reddish-gold surface, a combination that almost nobody had predicted, and that nobody who has seen the image can easily forget. It took more than 15 months for the spacecraft to send all of its 6.25 gigabytes of photos and data home, because the spacecraft was roughly 4.5 light hours from Earth, and could only transmit 1 to 2 kilobits per second. Every pixel of those images was hard-won across the vast distances of the outer solar system, arriving in fragments over more than a year of patient waiting. Then, New Horizons kept going. Because the laws of orbital mechanics dictated its path, because the fuel budget allowed for a modest course correction after Pluto, and because a group of astronomers scanning the sky with a Hubble Space Telescope in 2014 found a small, faint target sitting almost exactly along the spacecraft's projected trajectory, there was a second act. The target was a Kuiper Belt object, an ancient, primitive body orbiting in the frigid outer reaches of the solar system beyond Neptune's orbit. It was given the nickname Ultima Thule, and later officially named Arakoth, a word meaning sky in the Powhatan Algonquin language of the indigenous peoples of the Chesapeake Bay region of North America. On January 1st, 2019, New Horizons flew past Arakoth. New Horizons came to within just 3,500 kilometers of the surface, making it the most distant target in history ever explored up close. What it found there was something that looked, at first glance, almost comically simple compared to the drama of Pluto. Arakoth resembles, in the most technical of descriptions, a snowman. 2 rounded lobes, one larger and one smaller, gently pressed together at what scientists call the neck, the narrow constriction where the 2 bodies are joined. End to end, the overall shape of Arakoth measures about 35 kilometers long, about 20 kilometers wide, and roughly 10 kilometers thick. By cosmic standards, it is a tiny thing, You could fit it comfortably within the boundaries of a mid-sized city. And yet, Arrokoth may be one of the most scientifically important objects a spacecraft has ever visited. The reason comes down to what Arrokoth actually is: a fossil. Not a fossil in the biological sense, but in the deeper and more fundamental sense of the word. Arrokoth is a preserved relic of the conditions that existed in the young solar system more than 4 billion years ago, when the sun was newly born and the planets had not yet fully formed, when the disk of gas and dust and ice surrounding our star was still in the process of clumping together under its own gravity to build the worlds we know today. The objects that eventually became the planets started as smaller bodies called planetesimals, the true building blocks of planets, and for decades, scientists had argued fiercely about exactly how those building blocks came together. Was it through violent, high-speed collisions over long timescales, objects smashing into each other again and again until they grew large enough to dominate their neighborhoods? Or was it something gentler, a kind of gravitational choreography, where clouds of material collapsed inward on themselves and coalesced slowly, like a gentle gathering, rather than a demolition derby? Arrokoth answered that question definitively. The uniform color and composition of Arrokoth's surface shows the Kuiper Belt object formed from a small, uniform cloud of material in the solar nebula, rather than a mishmash of matter from more separated parts of the nebula, supporting the idea that Arrokoth formed in a local collapse of a cloud in the solar nebula. If violent high-speed impacts had been responsible for building Arrokoth, the two lobes would show signs of dramatic deformation, fractures, compositional differences, the scars of catastrophic mergers. Instead, the surface is smooth and uniform in color, a muted reddish hue from top to bottom on both lobes. The two bodies that joined to form Arrokoth appear to have drifted together in a slow, gentle spiral, drawn by their mutual gravity into a tender contact binary, colliding at very low speeds, more like how you might walk into a wall as opposed to supersonic impacts. As principal investigator Ellen Stern put it, Arrokoth may have been even more important scientifically than Pluto. It settled a decades-long debate about how planets are born. Arrokoth's geology supports the streaming instability model of planetesimal formation, where collision speeds of just a few miles per hour allowed objects to gently accumulate to build Arrokoth in a local area of the solar nebula, undergoing gravitational collapse. This model, called the streaming instability or particle cloud collapse model, has now become significantly strengthened by what Arrokoth revealed, and the implications extend beyond just one small object at the edge of our solar system. If this is how the building blocks of our planets formed, then it changes our understanding of how planetary systems throughout the entire galaxy come together. Every time we look at another star system and wonder whether it might harbor worlds, the lessons of Arrokoth are part of what informs that question. Even more recent analysis has found something additional and strange in Arrokoth's structure. The surface contains large mound-like features, whose sizes and properties appear strikingly similar to each other, hinting at a common origin in the formation process. Researchers presented findings at a 2023 meeting of the Division for Planetary Sciences, suggesting these similarities reveal new insights into how Arrokoth was built from its original cloud of material. And in early 2024, a separate study explored whether Arrokoth might still harbor ancient ices deep within its interior, preserved volatiles from the very beginning of the solar system, sealed inside its porous, fluffy bulk. Researchers found that the double-lobed object may have ancient ices stored deep within it from when the object first formed, potentially locked away from any warming or processing by the sun for over 4 billion years. To hold something so ancient and so chemically pristine is extraordinary. Arrokoth is not just a relic of the early solar system. It may be a time capsule containing the actual chemical ingredients from which our world and every other planet was built. Now zoom out. Let that sink in for a moment. In the span of a single mission, a spacecraft about the size of a grand piano, running on less electrical power than a pair of household light bulbs, traveling at nearly 50,000 kilometers per hour, humanity obtained the only close-up views it has of a potentially ocean-bearing world with active cryovolcanoes and nitrogen glaciers, and the only close-up views it has of a pristine 4 billion-year-old fossil from the dawn of the solar system. Both of those firsts happened on the same spacecraft, on the same journey outward from the Sun, separated by less than 4 years of travel. It is one of the most extraordinary scientific doubleheaders in history, and here is what makes those images so irreplaceable, so precious in a way that can be hard to fully articulate. New Horizons is the only spacecraft in the Kuiper Belt, and the only one currently planned to go there. There is no follow-up mission to Pluto in development, no orbiter, no lander, no second flyby. The James Webb Space Telescope has observed Pluto from afar, adding to our understanding of its surface composition and its faint atmosphere, but Webb operates at enormous distances from Pluto and cannot resolve the surface features that New Horizons revealed. The Hubble Space Telescope, before New Horizons arrived, showed Pluto only as a blurry handful of pixels. That is what awaits us again. The best views that modern ground and space-based telescopes can produce of Pluto fall infinitely short of the images taken from 12,500 kilometers away in the summer of 2015. Those images, the heart, the mountains, the blue haze, the crescent glow, are likely to stand as humanity's best views of Pluto not just for years, but for generations. New Horizons is currently traveling at about 49,200 kilometers per hour and covering around 480 million kilometers every year. Its mission will continue until it exits the Kuiper Belt in 2028 or 2029, at which point NASA may decide to shut down the mission. The spacecraft's plutonium fuel generator could keep it operational into the 2040s, by which time the probe will be around 15 billion kilometers from the Sun. The mission team has been searching for a third Kuiper Belt object close enough to the spacecraft's trajectory to enable another flyby, scanning the sky with the Subaru telescope in Hawaii for a suitable candidate. As of June 2024, no suitable targets had been found. The window for such a discovery is narrowing with every passing month as New Horizons pushes deeper into the outer belt, and the geometry of any possible diversion becomes increasingly impractical. The mission has not been without its struggles on Earth either. In 2025, the White House's proposed NASA budget would shut down New Horizons mid-flight, and the mission's future has been actively debated in the United States Congress. The cost to keep New Horizons running is modest by any government standard, roughly $10 million per year. But in an environment of deep budget pressure, even that modest figure has been the subject of intense debate. The scientific community has pushed back forcefully. You do not build a nearly $1 billion spacecraft, send it on a 9-year journey, have it rewrite what we know about the outer solar system, and then switch it off while it is still healthy, and transmitting data from a region of space that no other human instrument can reach. The argument is not only scientific, it is civilizational. We are the only species in the known universe that has ever built something and sent it to another world to look. The decision about whether to keep looking or to stop says something about who we are. Think about what it means that these images exist at all. Pluto was discovered in 1930 by a young astronomer named Clyde Tombaugh, working at the Lowell Observatory in Arizona. For 85 years after that discovery, Pluto was nothing more than a point of light, not a world, not a place with mountains and glaciers and moons and seasons and an atmosphere that glows blue. Just a point. A dot in a photograph, barely distinguishable from the background stars, moving slightly from one night to the next. An entire world, sitting at the outer edge of our solar system, invisible to us in any meaningful sense for most of a century. New Horizons actually carries 30 grams of tour. Clyde Tombaugh's ashes on board, a tribute to the man who first spotted that point of light. His remains are now the farthest from Earth of any human material in history, sailing through a darkness he never lived to see, past the world he spent his life discovering. What the images show us is not just Pluto, they show us the Kuiper Belt itself, a vast ring of icy worlds orbiting the Sun beyond Neptune, containing hundreds of thousands of objects, perhaps more, each of them potentially as complex and surprising as Pluto. In September 2024, the New Horizons team detected evidence of an unexpected population of Kuiper Belt objects, and observations from the Subaru telescope suggest the Kuiper Belt may extend significantly further than previously theorized. There may even be a second, more distant belt of similar objects beyond the one we currently know. Each of those worlds is a time capsule. Each is a chapter of our solar system's biography, written in ice and rock and ancient chemistry. And we have visited exactly 2 of them up close. 2 out of potentially hundreds of thousands. The images of Arakoth haunt in a different way than the images of Pluto. Pluto is dramatic. It demands your attention. Arakoth is quiet. It hangs in the blackness, small and reddish, its 2 lobes gently touching like an embrace frozen in time for 4 billion years. It does not look extraordinary at first glance, but knowing what it represents changes everything. Knowing that it was assembled grain by grain in the original dust cloud that surrounded the young sun, that its 2 lobes slowly spiraled together under their own tiny gravity over millions of years, that it has sat out there in the deep cold largely unchanged since before the Earth existed. Knowing all of that transforms the image. Arakoth is a window, not into alien strangeness, but into our own origins. The material that built Arakoth is the same kind of material that eventually, through collision and accumulation in time, became the Earth, became the oceans, became the chemistry from which life arose. There is no return scheduled. No human hands will touch the soil of Pluto in any of our lifetimes, and probably not in the lifetimes of our grandchildren. As New Horizons principal investigator Alan Stern has stated, we are the only spacecraft out there. There is nothing else planned to come this way. And so the photographs remain what they are. A brief, extraordinary opening of a window that has since been closed again. A few hours in July 2015 and a few hours on the first day of 2019 when a small machine sent by a civilization on a small world around an ordinary star looked closely at two ancient frozen places no one had ever seen and found them far stranger and far more beautiful than anyone had dared to imagine. That heart on Pluto's surface, Tombaugh Regio, was named for the man who spent his life staring at photographs of the sky, searching for something he could not yet see. He found it. And then, 85 years later, we finally truly looked at it. The last clear image we may ever have of that heart is the one that already exists, frozen in the cameras of a spacecraft that has now traveled twice as far from the sun as Pluto itself, carrying a handful of dust that was once a man, sailing outward into a darkness that goes on forever. The question it leaves behind is a quiet one, but it never stops echoing. Given how much we found in just 2 brief glances, and given how much of the Kuiper Belt remains unseen, what else is waiting out there that we have not yet thought to look at?